Hello everyone. In this video, we will learn about the ridge regression. In linear regression, the objective is to determine the best fitting hyperplane by minimizing the sum of square differences between the observed and predicted values. When those variables are highly correlated, linear regression will become unstable and it is going to give some unreliable estimates. Ridge regression will address this problem. It's going to introduce a regularization term that will penalize those coefficients, and it stabilizes the model, also reduces the risk of overfitting. Consider the table including years of experience and salary. Here the data looks linear, and the linear regression is used to model the relationship between the years of experience and salary. When we try to fit a line to the data, we will end up in getting a line y cap equal to 23.17 plus 3.54x. When the years of experience is known, we can easily compute the salary. This is reflecting the relationship between the years of experience and salary. When a model is trained using only two data points, it will lead to several problems that will result in errors. Because of the limited data, the model is going to create a perfect fit. That is, let us consider some data points here. In case if we are trying to create a perfect fit, is that is possible, but that is going to result in overfitting. The reason is when new test data are introduced, in case if these two data points are the new test data, the model will struggle a lot and it leads to high error rates. This is going to increase the model's sensitivity, indicating a high variance because of the overfitting, which results in overfitting. Introducing bias in ridge regression is involving a regularization term that's going to penalize the large coefficients. Generally, this is going to avoid overfitting. By accepting this small amount of bias, ridge regression definitely will improve the model's ability to generalize to new data. In ridge regression, the regularization parameter lambda controls the strength of the penalty. The choice of lambda is crucial and we can determine through cross-validation techniques. There are a lot of cross-validation techniques and these techniques will minimize the error and helps us to achieve a balance between the bias and variance. The first technique, leave one out cross-validation. Here, we are leaving out one sample at a time and the remaining samples are used for training. In the k-fold cross-validation, we will divide the data into k subsets. We will train the model on k-1 subsets and evaluates it on the remaining subset. This is going to get repeated for k times. Then stratified cross-validation. Dividing the data into subsets, at the same time we maintain the original class distribution, ensuring they have the same proportion of classes. Suppose if in a data set we have 70% of the data belonging to the label male and 30% of the data belonging to the class female. If this is the case, when we are considering the data, 70% of the data would be taken from the male class and 30% from the female class. This is how the stratified cross-validation is done. Then time series cross-validation. This is evaluating a model's performance on time series data, where we train on the past data and test on the future data. Let us consider this data. Let X represents the feature matrix and Y represents the response vector. The next matrix is X suffix B. In this matrix, we are adding a column of 1s to the matrix X. This is enabling the inclusion of an intercept term, and this is ensuring that the regression line will adjust vertically to capture the relationship between the independent and dependent variables. X representing the feature matrix, Y response vector, XB a new matrix which has a column of 1s to the matrix X. We can compute W using this ridge regression equation, X transpose into X plus lambda into the identity matrix and the whole inverse into X transpose into Y, where W is representing the vector of coefficients and lambda is the regularization parameter. The first step is, let us choose the regularization parameter lambda as 1. Here, the first factor to be computed is X transpose into X. So for the X matrix, we do compute the transpose. This is X transpose, this is X transpose. We are finding the product of X transpose with the actual X. The first product what we are computing is this X transpose into X, which gives a result 10, 91, 91, 1042. This is the value of X transpose into X. Here, the next step is, after the computation of X transpose X, we have to compute this value X transpose X plus lambda I, where lambda is the regularization parameter and I is the identity matrix. Upon finding the summation of these two, it results in this matrix. Now, the next step is, we have to apply the inverse for the same equation, this one. So this is found, and when we are applying the inverse for the same matrix, we are getting a value like this. So this is the final value of it. After which, we have to compute X transpose into Y. This is X transpose, this is X transpose, and this is going to be Y. When finding out the product of the two, it results in 5546230. In this equation, we are computing X transpose into X plus lambda into the identity matrix, applying the inverse, which results in this matrix, and then calculating X transpose into Y results in this matrix. When we find the product of these two matrices, the resultant matrix is 17.5 to 3.97. Once these values are computed, we can substitute this in the prediction equation. So the prediction equation based on the ridge regression is this. Salary is equal to 17.52 plus 3.97 into years of experience. In case if we want to predict the salary for an employee who has 10 years of experience, now we are substituting 10 in the place of years of experience. So the final predicted salary would be 57.22 in thousands. Now this is the equation which can be used to predict the salaries based on any years of experience. Now in this video, we have learnt about the ridge regression with some simple examples. Thank you.